Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. The Honorable Mrs. Dr. Mia Sriniati SGZ MSc as a Dean of the Faculty of Health Sciences and Technology. The Honorable Mr. Dr. Renan Prasta Jenie STPMT as a speaker that will be giving out material today. The Honorable all lecturers of the Faculty of Health Sciences and Technology and my proud participants who have been present at today's event. Ladies and gentlemen, I would like to introduce myself. I am Annisya Nur Rachmi as a student of nutrition study program at Binawan University. It's a precious chance for me to be your master of ceremony on this very special occasion. First of all, let us pray and praise to Allah Subhanahu wa Ta'ala. Because of His blessing and mercy, we can come together without any obstacle here, with healthy condition in the event of health scientific update. We would like to say thank you and welcome to the participants for attending today's event. On this nice occasion, let me deliver the structure of the event today as follows. The first one is opening. Second one is introducing the speaker. Third one, presentation of material by the speaker. Fourth, the question and answer session. Fifth, photo session. And the last one is closing. Let's open this event by saying Basmalah. Bismillahirrahmanirrahim. Ladies and gentlemen, now we come into the main point of health scientific update, which will be delivered by Mr. Dr. Renan Prasta Jenie STPMT. But before that, I would like to read the CV of Mr. Renan. He is a lecturer of nutrition department at Binawan University. His bachelor degree is in agriculture engineering from Bogor Agriculture University in 2005. Master degree in software engineering from Bandung Technology University in 2008, and PhD degrees in human nutrition from Bogor Agriculture University in 2018. Now, he's going to share the material about the research progress on non-invasive blood hemoglobin level measurement medical device. All right, to Mr. Renan, did you connect with us?
Thanks, Mbak Anissa.
All right.
That's
Mr.
a really warm
Renan,
welcome.
time and place are yours.
Okay. Let me share my desk. Sorry. Okay, it's already seen?
Yeah, sure.
Okay, thanks. This is our team research from back then in 2015. They actually start much earlier at 2010 or 2005. So this is me, Renan, lecturer in Department of Nutrition. You can use my contact here if you need to ask further about what I do. If anyone have any question, feel free to write it down at slides up Google 9L or 9 because I have difficulty hearing, so sometimes I misinterpret what you are saying. So better if you write it down and I shall show it just like this. Okay. So we start by this. What is hemoglobin? I think I don't need to explain to you further because you are from nutrition. But for general purpose, let's say that hemoglobin is a cell or a special cell in human body that carries the oxygen using the heme. Heme is the green one here that conceal one material or element of ferrum, which will be locking with oxygen. Yeah. Its hemoglobin carry for F for heme object. So why we wanna measure hemoglobin? Our real target is actually much further. We have something like called I forgot to. Sorry. Yeah. From this paper, we actually want to measure hemoglobin A1C, Hb alpha 1C, the linking between hemoglobin and glucose, where this can show how close person to diabetes or metabolic syndrome state. in normal person, his hemoglobin is kind of like this, but there's a special some called glycated hemoglobin, hemoglobin with glucose just attached on the skin, which uh, can be a surrogate marker, just like water. Mm, when we have so many HB1OC, our glucose level is kind of high from normal in at least in 3 months back. So in short, our hypothesis is HB1OC is a function of blood glucose level, or blood glucose level history, and blood hemoglobin level. That's why, because we already done so many research on blood glucose level, we also need to measure blood hemoglobin level to catch this one, to measure this one. So how to measure this hemoglobin? Based on this paper, method of hemoglobin estimation, and this is the first one that I read, and this is a really good paper. You should read it later. This paper described the method and the advantage of every non-conventional methods currently in use. Taskfish, copper sulfate, Lathifah, and you can read it yourself. Then, so what is the main problem? Can Annisya guess? Mbak Anissa? Could you guess one one big problem with these 8 methods?
I'm sorry, sir. I couldn't.
Okay. Can you guess one problem that really plague the measurement of hemoglobin? Can you guess one?
Anemia.
No. Actually, much simpler. You can see. Because it's involves using needles. That's the main problem. And yes, needles is scary. So we want to find methods to measure hemoglobin, and that indirectly using we call it spectrophotometry. Okay, we use we use light source, and we use light sensor to indirectly measure the hemoglobin, glucose, or any biomarker inside the human skin. At least as long as it's not hot enough, light won't hurt you. Okay. And we know that based on certain wavelength, hemoglobin, hemoglobin in this deficit state and this normal state respond differently on certain wavelength. So naturally, that's how oximeter born, using red light and infrared light, and we give the light to the human skin and catch it with using photodiode. The difference between this become the function of oximetry. This is called pulse oximetry model. This is the earliest known models to measure indirectly hemoglobin. Okay, we'll come further, and we already know how oxyhemoglobin works, deoxyhemoglobin works, bilirubin works, and exceptionally melanin works. So then what is the step to develop a non-invasive, etc.? Using our works from I work here in Institut Pertanian Bogor with our friend in now called BRIN, Badan Riset dan Inovasi Nasional. Back then it's BPPT, Badan Pengkajian dan Penerapan Teknologi, and PT Tesena Indonesia. We came out with a simple general protocol for ethical conforming development for non-invasive blood biomarker measurement, which came in 4 parts. We called it pre-protocol preparation, phase 1, phase 2, and etc. Which actually in common with technology readiness level from 1 to 3, 4, TRL 5, 6, 7, 8, and 9. With also mimicking the clinical trial phase O, phase 1 pilot, phase 2 feasibility, pivotal, and post-market. And you can read the right one, the detail that we are doing that to in its stages. From that, using that technology, we make our research roadmap, which came from theoretical basics. What is hemoglobin? How it flows in human body? Anatomy, physiology. You better than me in his case. I am a software engineer. Okay. Then we actually extract the human blood from human body, and we measure it using spectrophotometer to see how it's uh, how the spectrum on its samples. We also buy standardized control sample from Biorad, and okay. After we test the blood, we actually make a simple contraption using cuvette. We drip our blood there and using our set of machines, light and sensors, and we get the system to measure. After we get the how the hemoglobin can be measured using in vitro system, we go to human. We ask about 30% to measure and we compare it to the gold standards. In this case, we ask Prodia to as our reference. Our target, we try to enter the market at 2023. As maybe in real, we will be entering at 2024, but we are going there. Okay. So this is our research from back then, from 2008. There are several research, there are publications going on. And you can see that hemoglobin research and glucose research go hand in hand because they're related one to each other. So what sensor to use? Okay. I would like to introduce you what called ferroelectric material. Or we can call it in simple a sensor. A sensor is a device or a substance that changes its characteristic based on outside or inside impulse. Like, okay, let's say a sensor, when we give light, it will change the resistivity or the current. So we can use the difference between currents to measure whatever we are going to measure. That's called, in this case, we call it pyroelectricity. Sorry, pyroelectricity. Then what wavelength to use? Okay, this is my own research. Our team actually makes a very big effort in this case because this is the most crucial one, which wavelength. So this is one of our earliest reviews. So okay. We review wavelength that has been used from previous research, and we get 2 models. One model is using direct measurement from Kesari. You can see that the wavelength used is between 400 to 600, okay, something like that. Kesari for then if we some of them using pulse oximetry based method using 2 wavelength. One wavelength to detect deoxyhemoglobin and one deoxyhemoglobin, and one wavelength for using for measuring the hemoglobin, then we can see that what wavelength that they are using from you et al, Patakia et al, and so on. After that, we asked several people to volunteer their blood. We measured it using spectrophotometer, and here we got a good graph. The green one, especially, is the Pearson correlation between absorbance in that wavelength to the values of hemoglobin that we taken from, in that case, Prodia lab. And we can see that there's several good candidates from 1,000 to 500 A, B, C, D, E that we can use, especially in the places where the Pearson correlation is high. Furthermore, we we make next reviews on non-invasive blood hemoglobin measurement, and we can see that others use, especially in this range, between 500 nanometers to 1,000 nanometers. In places when the absorbance are actually low. There are only two exceptions where they use around 1,200 and something and 115. And this is the details. And I add all everybody. Okay. So, okay, this is 12 minutes. From on 2021, actually, we make research on UV spectrophotometric observation to find a wavelength for non-invasive blood hemoglobin level measurement of the device, and we find that in the visual range between 400, we can see that around 500 to 600, there are several good places to wavelength to use for non-invasive blood hemoglobin level on 500 and something to 500 and something, where the Pearson correlation is high. So we make a simple models using Zunzun multiform regression, and we can get the root mean square around 1 at 1.98 something, just a little smaller than 1 gram per deciliter, which is adequate for non-invasive blood. Sorry, how we call it? Okay, for a simple early detection device. Then, how we design our non-invasive blood hemoglobin level measurement medical device? If you are aware a simple model called von Neumann model, a computer, or in this case a device, usually have a central processing unit module which send the impulse to sensor modules, please measure, and the sensor module, in this case light and sensor, they give the analog spectra, which using analog to digital control change to digital spectra, and we started to our repository module, in this case a memory. Then we can use the data, we convert it to models that readable to human, in this case blood hemoglobin level measure itself. This is work by Ihsan Hardianto, a good friend of mine, non-invasive hemoglobin blood level measure system. He developed a model. In this case, he used reflectant methods. Here the sensor using two LED with different wavelength, and we catch the reflectance and we measure the model. This is the probe that our finger goes there. Then this is the main body, this CPU, which operates with cables to the sensor. This is how it's seen, and this is the real spectra. We modulate the light so it came with different intensity. This is the case when no light on. This is the case where the first light is on. This is the second light, and this is when the both light on in the same time, simultaneously. Then we are converted using fast Fourier transform model to a more robust wavelength with much wider range, so we can catch more wider difference between values. Okay. And this is the presentation. As you can see, it's actually quite small, between all 5 to the biggest one is around 1 to 5. And when we match it to multiform multiplication, we can get the accuracy of 94.2 with if you standard of 4.7. It's actually quite small. So what is the current state? Alhamdulillah, we already get our agreement with Badan Pengkajian Penerapan Teknologi and PT Tesla Indovindo on how we share and how we make the consortium to develop blood hemoglobin level on invasive. This is our current models. The current head is much sleeker in models. This is the sensor, and this is the light source. And this is the main body that we use for testing currently in Rumah Sakit Umum Brawijaya. We use 10-inch display as suggested by the doctors there, because they need it to accessible at all times. The models, we already have our digital engineering design. This is the design of main body, and this is the current design of our probes. And yes, Alhamdulillah, Rumah Sakit Umum Brawijaya agreed to test the device to around 1,500 people, and currently ongoing. And we already test our newest models in Institut Pertanian Bogor to each 60 people. Of course, we already have agreement between Institut Pertanian Bogor and Rumah Sakit Umum Brawijaya on how we run this clinical trial. Another Alhamdulillah moment, our article about this development already submitted and currently going in review, the second review in Helion. Helion is one of the quartile 1 Scopus journal currently available. And we already developed others to this time maybe we can send it to scientific report. We already our patent to istilahnya apa ya? Kita nyebutnya DGIP, Indonesia Patent Body, which called metode pengukuran kadar hemoglobin darah invasive, and this I hope this would be granted within 5 years. And we already have an intimate linkage with Kementerian Kesehatan Republik Indonesia. This is Dr. Sudhadikin Sahed. This is Bu Lili Sadia, the head of Direktorat Ketahanan Kefarmasian dan Alat Kesehatan, Indonesian Pharmacy and Medical Device Government Body. So our research is currently endorsed by them. We plan to do our clinical trial, especially to get our, we call it izin edar. I don't know how to say izin edar in English. Sorry. Market entry permit, maybe. Yeah. Our clinical trial to get the entry permit will be done next year. And our research already getting in Republican news. So we thanks the graduates that already done their parts in our research to support the non-invasive hemoglobin research. And our hemoglobin model already got 110 inovasi Indonesia 110 innovation awards. And we based on the same research, the sensor got another 113 130 karya inovasi Indonesia by professors, the best the most prospective innovation in Indonesia. So this is a fun time for us. Based on okay, already 22 minutes. Okay, this is scale lesson that we learned. In any research, when there's no money, we can turn. When no fund, no research, then nothing we can do. So we must send our research grant proposal. In my case, we sent it around 8 proposals a year, and we only got 1 from 8. 1 per 8 is only 12.5%. This is big. I wrote it at less than 20 because I also contribute also count the another labs that just adjacent to our labs. And furthermore, resource, people, funds, facility doesn't always available at one time. So when one is missing, then we cannot do anything of it. Currently, we lack people in from information technology background, especially from artificial intelligence. So we kind of get in a bum when we talking about how to interpret the spectral data that's currently available. And from our 28 people, only 3% that currently have clinical trial, good clinical trial, apa GCP ya? Sorry, only about 3 people that already have a certificate to run clinical trial from 28 people. So, and currently, Rumah Sakit Universitas Brawijaya is the only rumah sakit that willing to test our device. So, when later Ministry of Health asked us to how to do it multi-center, we kinda in the pinch now. Nah, that's why robust ecosystem is a must. We university cannot do any research alone. We need help from private sector. In this case, PT Tesla Innovindo. We need, especially now in grief, need community support. In this case, from hospital, from clinical, and from the users. We are lucky that we in close with the government body, in this case Badan Pengkajian Penerapan Teknologi, now Badan Riset Inovasi Nasional, and we also kind of lucky that we are in close proximity with technology unit provider vendors. But one point, when one party is missing, this research is will not run as what we want. Then this is for every student here. No research is waste when planned well. E- Especially for non-graduate, especially for undergraduate students. Your research is mostly not counted from how it's new or how it's novel. Verification research is okay. It's actually your job. Verification research is a research that someone already done, and you done it again using in different contexts. That's actually a good thing because we want to know the reliability of any methods or any device that already done. And I need help from student here. Nah, this is for current state in uh, clinical trial. Until now, we are still confused about the real steps from ideas, research to distribution permits, and where to start research, where to do clinical trials, how many places, how many subjects, and how to where to test or device from the safety setting. Okay. Thanks God, the consortium already made, and between Aspaki, kemudian Gakeslab and government, and in close within around 1 or 2 weeks, we will meet to make a grand design on how to do all of this point. And for research in medical device, we can't admit that this is a latent problem, that administrative overhead for medical device research is huge. 60 to 80 times time allocation goes to administrative affairs, like how to make commitment to several bodies, how to get subject or respondents, how to write agreement. That's really the hardest thing, rather than the actual clinical trial itself. So I thanks to everyone here that listened to my uh, presentation, and I give the time praise to Anissa again. Thank you very much.
Okay. Thank you, Mr. Renan, for the knowledge which have been given to us and made useful for us. All right, before I give the conclusion from your material, there is a question from Taufik in the chat box. Let me read. Yes.
Wait.
And he said, di roadmap, saya melihat ada modul Raspberry. Fungsi dari modul tersebut untuk apa dalam proses pembacaan HbA1c? And then also say, di penelitian dokter, sampelnya kelihatan adalah orang normal. Apakah pernah dilakukan uji coba pada orang diabetes mellitus dan dibandingkan hasilnya dengan HbA1c atau pemeriksaan glukosa darah? Could you please answer the question, sir?
Okay, this is really a good question. Taufik, should I answer it in Indonesia or in English?
Maybe in Indonesia.
Oke, ya udah, Taufik. Gini, masalah modul Raspberry di sini untuk menggantikan modul komputer untuk pengolahan data, menerjemahkan data spektra yang didapat dari sensor, kemudian mengolahnya dengan teknik kejelasan buatan. Dalam kasus ini multi-formulated regression sama artificial neural network, fast artificial neural network, untuk mendapatkan nilai HB-nya. Jadi seluruh model eksekusinya pada saat itu dilakukan di atas modul Raspberry. Kalau yang sekarang kita menggunakan STM235. Nah, semoga cukup menjawab tuh pertanyaan pertama. Nah, untuk pertanyaan kedua, iya, memang sampel kita pada saat ini kalau untuk glukos paling banyak masih orang normal. Nah, sementara alhamdulillah dengan kita bekerja sama dengan kliniknya Rumah Sakit Universitas Brawijaya, semoga kita bisa mendapatkan orang-orang di level level nilai glukosa dan HB yang lebih ekstrim, baik yang di tinggi dan yang di rendah. Semoga cukup menjawab untuk pertanyaan Mas Taufik. Ada pertanyaan lanjutan? Baik, Mas Taufik.
Sepertinya tidak ada sih, Pak. Hanya itu saja.
Oke.
Okay, thank you for Mr. Renan for the great answer. That was very nice answer. All right, let me deliver the conclusion about the material. Hemoglobin is found in the red blood cells that transport the oxygen from lungs to body tissues and returns carbon dioxide from tissues back to lungs. But hemoglobin level measurement is an essential part of global attempt at reducing anemia. The standard way of measurement of hemoglobin concentration is to prick one's finger or arm to acquire a sample of blood, and the sample is later analyzed via one of the different chemical methods available. Non-invasive method allows pain-free continuous monitoring with risk of infection extremely low. The researchers also classify some such articles into 4 main groups, such as non-invasive blood hemoglobin level measurement methods, reference-invasive blood hemoglobin level measurement methods, light source wavelength used for each method, and omitted poor quality articles. There are several methods of non-invasive blood hemoglobin level measurement, such as PPG or photoplethysmography. It's a simple optical techniques used to detect volumetric change in blood in the peripheral circulation. Use computer vision or image processing techniques to quantify blood hemoglobin level on human skin, but they have to use sensors to measure reflection from blood hemoglobin level on human skin and etc. All right, that was the conclusion about the material. Okay, and right now I would like to remind for the participant here, you can fill the attendance link in the chat box and the event and at the end of the event. All right, the next one is another session. Okay, here a question from the first panelist, that is Eka Almas Lathifah. For the Eka Almas Lathifah, please turn on your camera and microphone, and then you can start to ask our speaker.
Halo.
Hello.
Yeah, hello. Can you hear me?
Yes. First of all, I want to say sorry because my signal is bad because it's raining and I cannot open my camera. So I hope you all guys can hear my voice. I want to ask to Mr. Renan. Regarding the title of this research, where with the progress in this hemoglobin measure tool, do you think there is still a shortage of this hemoglobin measurement tool itself? Thank you.
Okay. That's a good question, but okay. The answer is kind of convoluted because different from blood glucose. Blood glucose, when for people who need it, they will usually use it so many times a day, like morning, after meals, before meals, and etc. Around can be around 6 to 12 shots a day. That's for blood glucose level. But blood hemoglobin level usually only used 1 to 3 times when people expecting for pregnancy and delivery, or when government want to check or survey for anemia. In that case, we can see that the markers is very niche and kind of like a monopsony. The actual buyer of this, the actual potential buyer of this device is only government. So when we develop this, we must have a good agreement with the government. And then we can see the potential that this device can be put in every posyandu, puskesmas, public health center, and rumah sakit for early detection of anemia in every part in Indonesia, then we can see that the market's actually quite big in itself. Is this answer satisfying you? Hello? Are you satisfied with this answer, or maybe there's further question?
Yes, yes, I understand. Thank you.
Okay, thanks.
Okay, thank you, Mr. Renan, for the great answer. Okay, the next question from the second panelist, that is Mrs. Gusti Kumala Dewi SKM Mars. Please turn on the camera and microphone, and then you can start to ask our speaker.
Assalamualaikum. Can you hear my voice?
We can hear it clearly.
Okay. I'm so sorry because I have a bad signal.
Okay.
Okay. Okay. Before I ask a question, I have to permission to not active my camera because my signal is not good. Okay. Okay, Mr. Renan or Pak Renan, it's a very interesting research, and based on your explanation earlier, there are several things I want to ask. The first question is, can this hemoglobin measurement be used by health service like in puskesmas or hospital for the general public? At the first, I continue my question, or you will answer before?
If you may, please, I answered it one by one.
Oh, okay.
I have a really bad memory, so I need to conserve it. Okay.
Okay.
For that question, in this current state, no, not yet.
Okay.
We must undergo the clinical trial to get the distribution permit first, and after we get that permit, we can distribute it to any posyandu, puskesmas, and hospital around Indonesia. Is that satisfying?
Okay.
Okay. Okay. Yeah.
But can it be used later, Mr. Renan?
Okay. After we get the distribution permit, in case when the clinical trials show promises, then yes, the public health service around Indonesia can use the device.
Okay. Okay, clear. Okay, the second and the last question and the last question from me.
Okay.
What are the outcomes of this research? Enough.
You said outcome, yeah. Okay.
Hello.
Oh yeah. I hope I understand what you're asking about outcome. When we're talking about this research, we divide our output into two things. First, the first one we call it output, or something that we call for delivery. Then we get it the device itself, the prototype, the design that needed to support that device. Then we also deliver the publication needed and the patent needed for this device, the ethical clearance agreement for the device, and the distribution permit for this agreement. That's the output of this research. If you means the outcome as the the minimal quality of device, Then our target is to measure the blood hemoglobin level within 1 gram per deciliter error rate with the measurement rate around 1 measurement per minute or less. And the system, we can say, succeed the general safety procedures. Is that satisfying for your
Yes,
question?
it's clear. Yes, thank you, Mr. Renan. This is very interesting research. So hopefully in the future, your research can be used for the wider community in Indonesia in particular. Thank you.
Thanks a lot, Bu Gusti. Yeah, Maestra.
Okay, thank you, Mr. Renan, for the great answer. That was very nice answer. But before that, I saw some person bertanya lagi nih, Pak. He
Okay.
said, saya melihat modul dan device yang Bapak gunakan seperti Raspberry, infrared, and optical RE. Dan itu semua ada di smartphone. Apakah hasil penelitian Pak Renan bisa diaplikasikan pada smartphone?
Oh, okay, good. There are two questions from the Pak Taufik. This is a really good one. Now, can I answer it in Indonesia because the question is in Indonesia? Oke, saya jawab pertanyaan yang pertama dulu ya. Iya Pak Taufik, kalau metode yang kelemahan metode pengukuran HbA1 sekarang, kalau jumlah anemianya orangnya kurang, maka nilai Hb-nya juga jadi bermasalah. Nah, apakah penelitian saya bisa meminimalkan kelemahan tersebut? So far kita belum tahu. Karena uji sampai di sana belum dilakukan. Tapi minimal cara untuk mengujinya adalah dengan membandingkan HbA1, pengukuran HbA1 gold standard pada kasus orang normal dibandingkan dengan anemia, dibandingkan dengan menggunakan device yang kita buat. Jadi kita masih dalam perjalanan ke sana, minta maaf. Nah, terus modul yang digunakan seperti Raspberry, infrared, dan optical itu semua ada di smartphone. Apakah bisa diaplikasikan pada smartphone? Model data yang sekarang memang kita menggunakan smartphone untuk pengganti CPU, tidak lagi menggunakan Raspberry. Terima kasih banyak.
Okay, thank you for Mr. Renan. All right, ladies and gentlemen, this is the end of question and answer session from the two panelists. Thanks to the audience for listening to the Q&A session. Before we are going to end this event, the participants can fill attendance link in the chat box. Okay, last but not least, let's take a photo session. For all participants here, please turn on the camera. Could you please turn on the camera? Okay. Okay, and then we can start to take a photo from the first slide. And for the second slide. All right, thank you everyone. Okay, finally, we got to the last session in this event that is closing. Let's close this event by saying Hamdalah, Alhamdulillahirabbil alamin. As the master of ceremony, I would like to say thanks to the participants for attending today's event. Even guiding this event, I made mistakes. Please forgive me. We look forward to seeing you on the next event. Stay healthy and see you. Wassalamualaikum warahmatullahi wabarakatuh.
Okay. Terima kasih banyak kepada Bapak Ibu semua. Thanks a lot for everyone who present here.